dude. We can't really do experiments to show a difference in parallax between even our lifetime, dude. So in that perspective, it somewhat is legitimate, but you know the numbers that they give us are so astronomically huge that we really can't fucking put our mind to it. We can't really understand it. So either you kind
Yeah,
of
I
take it as
agree
a
with that.
yeah, either you
We're
take it as
talking
a
about scales that are so big we can't wrap our minds around it.
no, dude, you can't. I mean, even the Earth, dude, compared to what we are, is why flat Earth took off. Is because yeah, it looks like a flat horizon and stuff, but you know, you travel across California or you travel across Texas, and you see how small that is compared to the Earth and how big the oceans are and stuff. Yeah, you would see the flat horizon and empirically think that yeah, maybe we are in a flat plane, but it's much bigger than we think it is, and much bigger than we can fathom. And then you think of the universe, and it's infinitely times bigger, dude.
Yeah, can I is there a way to screen share for a second? I don't know. Some days I can do it naturally. Others it's like the host has to do it. And I don't understand.
No, you can screen share, but you have to be talking for it to be on the YouTube video,
Okay, let me.
unless the host lets you present it.
Okay, so I'm gonna
You
talk
you
for a
just got
second.
presented.
Okay, great. I'm gonna show a video that 444 The Truth made in chat. I don't know if he's still here, but he's a flat earther. But it's an example of somebody that is on the right track, trying to model what's going on and figure out why we see what we see. So what he's done is he modeled the Earth in some kind of 3D software, and it's some of the math is a little off. He's got the radius is 3671 kilometers, so it's a little smaller than what it should be, and it should be in miles. But
Yeah, but units don't
yeah,
matter really.
yeah, it's not going to be huge, right? But yeah, we're still short about what 39595. Yeah, so it's still a little smaller than it should be. The weird thing though is that he goes to miles in his distance up here. I don't think he did it on purpose. But what I wanted to show was that he's modeled the Earth here, and then he zooms in on a bunch of reference points he's made on here. So it kind of illustrates the Earth is really, really big point.
It's a massive world after all.
Yeah, so I want to pause right here and point out that this middle line is the 0 mark, and this big line right here is 125 miles away, and each of these increments in the middle are 10 miles. So what we see are, you know, the 65 to 75 mile mark is, once you zoom in on that sphere, right, it gets pretty flat looking from this point of view. Now, I'm not sure what his point is he's making here. It says this is around where he starts seeing curve at 125 miles, so I think maybe he drew a flat line from the 0 point, the axis 225, and said this is it.
Well, it
I'm
could
not,
be he could be basing that off of like a 90-degree field of vision or something.
yeah, I'm not. I asked for some clarification on that from him, but yeah, check it out. So I mean, you can see the pixels are breaking it up, but he also goes on to, let's see, like right here, these two lines are 10 miles, and we're at a slant, but you can still see that that horizon is pretty daggone flat looking. And he creates a marker on this three-dimensional sphere he created, and I think that's a point of view he's going to use later in the video. I think this is from, I'm not sure, his video doesn't have any audio to it, and the description doesn't really tell us a whole bunch. But what I'm like, this is what flat earthers should be doing, is taking the data provided and seeing if it makes sense, right? Using, you know, rather than just looking at videos that imply and assert and things like that, when you can actually model it and see. So like this whole horizon, from left to right, is, let's see, if that's the 205 miles, that's another 50, that's 255, that's another 20. This is like 280 miles left to right, and it's still relatively flat looking. There's a moderate amount of curve.
Yeah, I mean obviously we all agree, but
Sure.
this is why, you know, the Himawari 8 satellite has to get so far away from the planet. Because if you look at even the International Space Station, they're 250 miles up, or there's a range there, but let's say they're 250 miles up. That falls in their range. They still only see like what is it? I calculated it at some point. It's like a 3,000 mile diameter circle. They're not even seeing like the entire disk. They're still running it to Horizon, and
Yep.
it's so big. It's hard to wrap your head around it. It really is. I mean, if you just think about if you were a trillionaire and you could do whatever you wanted to do and you own your private jet, how long would it take you to visit every city in the world? I don't think you can do it in your lifetime. Like, it's just so big.
Yeah. Well, right here, it looks like our viewpoint is 6 feet off the ground, and those lines on the right, those are all 1 mile apart. And he's had to cut this globe up into flat surfaces. That's why we just got that hard angle right there.
Yeah.
But yeah, he just keeps zooming out until it turns into a giant circle. But then, yeah, this is what all of these folks should be doing: is trying to model it correctly and see if it works out.
Yep.
So the rest of y'all watching, go do that.
Well, that's one of the things that we keep running into is this reoccurring problem of the straw man argument. They're not understanding what the conventional model even predicts. The fact that the horizon is flat makes complete sense. That's what you would expect if you're 6 feet above the Earth.